They don't sell hydrogen?
No hydrogen. They don't sell barium nitrates. The nitrates. I would just like to use
Plus, I added a particular message. This is yeah,
So he's here to talk about his glycomics projects. I want to just mention that they've had several awards in the past few years, including the 2010 Muddiman Medal, and that they sent us past few years. Remember, it was an excellent lecture. And so I'm really looking forward to see the update on these projects involving glycomics.
Thanks, Jim. We're not doing structure or characterization of these glycans. We're just trying to quantify them in complex mixtures, and we're trying to build the reagents to make those measurements more effective. And so that's what I'm going to talk to you about today, this technique called INLIGHT, which I'll go into throughout the talk. And one of the things is that we've been focusing on over the past 15 years is working, so all this is directed at looking at ovarian cancer in both human and experimental model, animal model. As Joe said, I'm in the Dave Hercules lineage, which dates back to Lavoisier, and students in the room, you know, when you think about interdisciplinary research, multidisciplinary research, you think this is a new thing, this is the way the world's going. Well, Lavoisier actually said that you really want to get to the knowledge and cooperation of many scientists, even when scientists and technologists in branches of science might not even seem logical. And that's really what's going to propel things into the future. And this was actually said in 1793. So it's even more true today, though. Collaboration is very important, and that's the success of this particular project I'm going to talk about today. So in my research career, over 60% of the research is collaborative. The other 40% is when we're building foundational type science, fundamentals and mechanisms individual, but we don't know what it is. Okay, so there's lots of different things that result in this, but one of the things that we've been really trying to focus on is longitudinal studies in ovarian cancer. In the original grant that we wrote, we were supposed to get longitudinal samples from these women, but let me tell you, if you're working with a patient who's been diagnosed with ovarian cancer, the last thing in their mind is worrying about giving you more samples, right? It doesn't happen, so we had zero compliance with anybody who was interested in that, and so that's to be expected, I think. So what we decided when I went to NC State, so the origin of ovarian cancer is thought to be this monthly ovarian surface regeneration, this epithelial cell layer, when the egg is ejected into the fallopian tube. There's a lot of evidence. This comes back from Fatala in 1974. It's called the incessant ovulation theory. And basically, the more times you ovulate, the more risk you have of ovarian cancer. And that's why women with multiple children, they have lower risk of ovarian cancer. Women who take the birth control, lower risk of ovarian cancer. Nuns, higher risk of ovarian cancer.
You were talking about, way at the beginning, when you were talking about attaching more and more hydrophobic groups, and that once you got to a certain hydrophobicity, it just precipitated out. And I was wondering, if you wanted to use more hydrophobic groups, could you change the polarity of the solvent you use to allow the conjugate to stay in solution, or would that impair the hydrophobic chromatography too much?
Yeah. So if you put a more hydrophobic moiety on there, so it's all empirical data through lots of peptide work. But if you put a more hydrophobic group on there, you can still do killing because you're going to reconstitute basically 95% organic, and it's only soluble there. But it's just in the process. So that data was more, do we see an increased electrospray response beyond a certain point, and we don't. And so we're just going to go to around 800 angstroms squared and make a molecule somewhere there just to be safe. But it's empirical electrospray response data from peptides and their hydrophobic tagging to try to apply it to this. And it might turn out that the glycans, especially the larger ones, with so much hydrophobic surface area that we could even go even further. So we won't know that until we make some more molecules.
Similar line of question. Consider switching the polarity of your instruments as well as the polarity of the charge on the tag, using pyramid tags, initially we're going to work on field. Or something making positive mode. But negative mode would come down to negatives, negative charge. Such a
Yeah, so you mean put a permanent negative charge on something, or a acidic group of some sort. Yeah, we haven't done any of those. We haven't even tried to. It's funny, everyone's so afraid of negative ion mode. It seems that's where I started my whole career in electrospray with DNA. So everyone's so afraid of it, and including my students for some reason. But so I tell them, so we do a lot of imaging work, and I said, have you ever tried to do that imaging experiment in negative ion mode? Oh no. It's like some mystical box or something that they're afraid to hit the switch button. Same with this. I mean, we never even ran these in negative ion mode. I've never tried that. So just out of curiosity.
no, you go against like I said, cyanic acid.
Yeah. No, sorry. I mean, it's a valid point. So email my students. Please email my students.
And then when it does work in negative ion mode, people say, oh, you must have made some mistake.
Yeah, that's right.
Thank you.
Thank you.
Okay, thank you.